Question 4. I've started the diagram for you. You've got to put the 4 forces on this to get there. Well, as usual, there'll be a normal reaction here, pushing upwards. There's also some friction here, stopping it sliding. We've got the weight coming down here, so the weight is 10, so that's 10g coming down here. That's in the middle of the rod. So does it say how long the rod is? Yes, so we'll work that out in a minute. It tells you that A to B is 4 meters, and so it must be 2 meters to the weight there, another 1 meter to the peg, and 1 meter then at the end. There's one more force, and this is a smooth peg, so there's no forces acting in this direction at all. The whole force of that is coming out here at 90 degrees to that. We'll call that P, because they tell us to call it P in the next one. So there's all our forces, and to try and find out the normal reaction at P, what I'm going to do is I'm going to take moments about A. Let's try and see how is A turning. Pulling A down, we've got the 10g. How far away is that from the pivot? Well, it's 2, and the distance of this is away is this distance here, so it's cos 60. And going in the other direction is the force we're trying to find, which is 3 meters away. And look, that is the perpendicular distance there, so I haven't got any trig to worry about there. So this then equals 0. So P is going to be 20g cos 60, that's that bit there, divided by 3. And P turns out to be, you're told it in the question here, 32.7. That's what that works out to be. Now continue on to part C to try and find out the 2 forces, the normal reaction and the friction here. Basically what we're trying to do is split up this force P here into its horizontal and vertical components. And it might take you a little while to see this, but the angle we've got here is, look, this is 60 here. So if I've got Z angle there, this is 60 here. I'm actually going to use a 30 in that bit there. So the vertical bit here is going to be the sine of 30 times by P, and that's what the vertical part is. And the horizontal part of this one here is going to be the cos of 30 times by P. So let's put that together in the question there. So going in the vertical direction, we've got R, we've got P sine 30, so I've got 32.7 times the sine of 30, and I'm going to take off the weight as well, so minus 10g equals 0. So adding the 10g and taking off the other bit there tells us that the reaction there is 81.7 newtons. If I now go horizontally, the friction that way is directly opposite the 32.7 cos 30. So the friction is 32.7 cos 30, which is 28.3 newtons. Just moving down a bit to finish off, that we've been told of part D, took me a while to think about this, but it is simply, what we're saying is that the friction force here is 28.3, the normal reaction force here is 81.7, and all we're being asked for is, well, what is the resultant of those 2 things? So it's the good old vector stuff again, just to square them together, sort of square it, add square root, and so that distance there, or that force there, is 86.4. I think I got 86.5 when I did it the first time, but 86.4 newtons. The angle is the angle there. To find the angle, I'm going to do the inverse tan of 81.7 divided by 28.3, and that gives the angle you're looking for, 70.9 degrees. And the very last bit, like we've done before, find out the least possible of mu, value of mu, and so I'm going to use friction equals mu times r. The friction we've been using is 28.3, and divide by r, which is 81.7, and that gives you the 0.346 that you're looking for. That's it then. There's other ways of doing the angle, I suppose, would be the only thing to say. If you use that triangle there, then there's a 60, and you can figure out that from there. That's my longest video for years. Sorry about that.